Hi guys, my name is Jay Marbasco, and in this video, I'm going to discuss about pyrometers.
So what is a pyrometer? A pyrometer is a device that is used for temperature measurement of an object. The device actually tracks and measures the amount of heat that is radiated from an object. The thermal heat radiates from the object to the optical system present inside the pyrometer. Its principle depends upon the relationship between the temperature of a hot body and the electromagnetic radiation emitted by the body. When a body is heated, it emits thermal energy known as heat radiation. It is a technique for determining a body temperature by measuring its electromagnetic radiation. The optical system makes the thermal radiation into a better focus and passes it to the detector. The output of the detector will be related to the input thermal radiation. The biggest advantage of this device is that, unlike RTD and thermocouple, there is no direct contact between the pyrometer and the object whose temperature is to be found out. In an optical pyrometer, a brightness comparison is made to measure the temperature. As a measure of the reference temperature, the color change with the growth in temperature is taken. The device compares the brightness produced by the radiation of the object whose temperature is to be measured with that of a reference temperature. The reference temperature is produced by a lamp whose brightness can be adjusted till its intensity becomes equal to the brightness of the source object. For an object, its light intensity always depends on the temperature of the object, whatever may be its wavelength. So after adjusting the temperature, the current passing through it is measured using a multimeter, as its value will be proportional to the temperature of the source when calibrated. The potter Josiah Wedgwood invented the first pyrometer to measure the temperature in his kilns. He first compared the color of clay fired at known temperatures, but was eventually upgraded to measuring the shrinkage of pieces of clay, which depended on kiln temperature. Later example used the expansion of metal bar. So this is the schematic diagram of an optical pyrometer. As shown in the figure, the eyepiece is at the left side and the optical lens is at the right. The rheostat changes the brightness intensity of the reference lamp by changing the current passing through it. So to increase the temperature range which is to be measured, an absorption screen is placed between the optical lens and the reference bulb. So this red filter is placed between the eyepiece and the red bulb, which helps in narrowing the band of the wavelength. So how does it work? The radiation from the source is emitted and the objective lens captures it. The lens helps in focusing the thermal radiation onto the reference bulb. The observer watches the process through the eyepiece and corrects it in such a manner that the reference lamp filament has a sharp focus and the filament is superimposed on the temperature source image. The observer starts changing the rheostat values and the current in the reference lamp changes. This change in current can be observed in three different ways. So when the filament is dark, then the reference is cooler than the temperature source, and when it is bright, then the reference is hotter than the temperature source. The third instance is when the filament disappears. This means that the filament and the temperature source has equal brightness. At this time, the current that flows in the reference lamp is measured, as its value is the measure of the temperature of the radiated light in the temperature source. This is the spectrum where an optical pyrometer operates. It only operates with wavelengths limited up to 0.65 microns or the red visible light. These are the advantages of using a pyrometer. Its simple assembling makes it easy to use while providing a very high accuracy. It also doesn't need direct body contact to the object since it uses thermal radiation to measure its temperature. And lastly, this device can not only be used to measure the temperature but can also be used to see the heat produced by the object. Thus, optical pyrometers can be used to measure and view wavelength less than or equal to 0.65 microns. Using an optical pyrometer also has its disadvantages. One of its disadvantages is that it can only measure up to 700 degrees Celsius since its measurement is based on light intensity. It is also not useful for obtaining continuous values of temperature in small intervals. Its common application is measuring a very high temperature such as steam boiler, furnace, smelter industry, and highly heated materials. These days, it's more common for scientists and engineers to use entirely automatic digital pyrometers which are quicker and simpler and use two different types of detectors. Some measure heat by absorbing light, so they are essentially light detectors such as semiconductor-based light-sensitive photocells, a bit like tiny solar cells but with filters fitted in front so they respond only to a certain band of visible infrared or ultraviolet radiation. By sampling radiation far outside the visible spectrum, detectors like this can measure a bigger range of temperatures than older manual pyrometers. Modern pyrometers come in various shapes and designs. Some devices measure full spectrum of emitted radiation, so they're called total radiation or wideband pyrometers. They tend to use heat-based detectors such as thermopiles.
So that ends my discussion about pyrometers. I hope you enjoyed this video.